So let's start the lecture by graph representations. In the last lecture we saw there are two forms to represent a graph. One is adjacency list and the second one is adjacency matrix. Now let's see how can we represent the graph given in the screen in using both the two methods. Okay, so let's start with the adjacency list. Okay, so let's name it adjacency list. Okay, so if you see we have 6 nodes and they have edges, so we can create adjacency list for 6. So this will create a adjacency list for six nodes. So basically this will create an array of 6 length of size 6. Okay, so and we'll represent a graph such that node 1 will be represented by index 0, node 2 will be represented by index 1, so node 6 will be represented by index 5. Okay, so that's how we'll proceed. So if we will do this adjacency list of 0, this will give us the adjacency list corresponding to node 1. Okay, now let's see the graph. So node 1 has 3 edges, one edge going from node 1 to 1, other from 1 to 2, and third from 1 to 5. Okay, so adjacency list of node 0, so this will be again a list. So adjacency list node 0 push. How do we insert a value inside a list? Let's see. Inserting into so we the way we insert is pop and append. Okay, yeah, so list dot append will be, so it will append 0 because node 1 is represented by index 0, so adjacency list 0 will append 0, so this will add an edge from node 0 to 0. Again there is an edge from 1 to 2. Basically that means there is an edge from 0 to 1. So and the last one will be node of 5, which will be represented by value 4. So 4. The reason we are doing 1 minus the node index will be because inside an array index starts from 0. So we can represent node 1 by index 0. So that's why we are starting the node count from 0 instead of 1. Now we are done with the 0, that is node 1. Now let's put node 2. Okay, so node 2 will be adjacency list 1, will append, there's an edge from node 2 to node 1, that is 0. Again from 2 to 3, that is 2. From 2 to 5, that is 4. Now we are done with this node also. This node, this node. Let's go to node 3. So adjacency list node 2 dot append. So there is an edge, this edge 1 dot 2. There is an edge from 3 to 4. That means 2 to 3. We are done. There are only 2 edges, so we are done with this. Now let's go to the node 4. So node 4 will be represented by index 3. So node 3 append. So there is an edge from 4 to 3, that is 3 to 2. This edge, so this will be represented by 4. So there is one more edge from this 4 to 6. This will be represented by 5. Okay, so we are done with this also. Now let's create a list for node 5. So there is an edge from 5 to 1, so 5 to 0. There is an edge from 5 to 2, so that will be 4 1. There is an edge from 5 to 4, that will be 4 to 3. So we are done with the 5 also. Similarly, let's do for the node 5, that is node 6. So for node 6 we will do adjacency list 5. So there is an edge from 6 to 4, so that is 5 3. So this will be a representation of the graph using adjacency list. Now if you want to visit all the edges for say node, all the edges for node say 3, so what we'll do is we'll iterate on the edge in adjacency list. This will give us all the edge. Okay, so let's try running this. Let me make it runnable. Okay, let's print it. Yeah, so my mistake was this should be a list, so it cannot be an integer. Let's try running it again. Yes, so what we printed is we are printing all the edges for the node 3. Node 3 is connected to node 2 and 4, so that's what it got printed 1 and 3. Since in the code we are representing the node as node minus 1, so for node 3 it gives 2 and 4, that is 1 and 3, 1 plus 1 2, 3 plus 1 2 4. Okay, now let's try to print edges for node 6. So this will become 5. Let's run it again. We will get a value of node 6 has only node 4 as a edge, so it will only print 3. So let's try running it. 3. Yeah, so that's how you represent a graph using adjacency list.